What would happen if we detonated a nuclear bomb on the moon? Imagine that for a moment. A sudden brilliant flash against the familiar gray canvas of our celestial companion. A silent, violent testament to human power, or perhaps human folly, etched onto the face of the moon for millennia to come. This isn't merely a fanciful question whispered in late-night science fiction discussions. It's a scenario that has been seriously, if secretly, contemplated. The very idea forces us to confront the limits of our ambition and the potential consequences of wielding forces that can reshape worlds, even one as distant and seemingly untouchable as our own moon. The moon, a silent observer of human history, would suddenly become a victim of it. Its serene, pockmarked face, a map of cosmic impacts over billions of years, would gain a new, artificial scar. This scar wouldn't be from a random asteroid or comet. It would be a deliberate mark, a signature of humanity's technological reach. The implications ripple outwards, far beyond the immediate vicinity of the blast. How would such an event alter our relationship with the cosmos? How would it change our view of ourselves as a species capable of such profound and potentially devastating intervention in the natural order of the solar system? The questions are as vast as the space between worlds. Consider the sheer audacity. To target the moon, our constant companion in the night sky, the inspiration for poets, lovers, and scientists alike. To unleash upon its tranquil surface the most destructive force we have ever conceived. This wasn't always just a hypothetical question. During the Cold War, the tension between the United States and the Soviet Union was so thick, you could almost see it. Both superpowers were desperate for any advantage, any display of technological or military superiority. The space race was a major front in this ideological battle. Getting to space first, putting a satellite in orbit, sending a human beyond Earth. These were monumental achievements. But what if you wanted to make an even bigger statement? What if you wanted to show the entire world, in one undeniable flash, just how powerful you were? This was the chilling context for Project A119. In the late 1950s, the United States Air Force secretly conceived a study of lunar research flights, better known as Project A119. The primary objective was astonishingly bold: to detonate a nuclear weapon on the moon. Why? The reasoning was multifaceted, a product of Cold War paranoia and scientific curiosity. A visible nuclear explosion on the lunar surface would be an unparalleled show of force, a clear message to the Soviets, and indeed the entire planet, of American capabilities. So what would a nuclear explosion on the moon actually look like and do, scientifically speaking? First, forget the iconic mushroom cloud. That's a terrestrial phenomenon, a result of superheated air rising and interacting with a dense atmosphere. The moon has virtually no atmosphere, just a wispy exosphere. So, a nuclear detonation there would be very different. Instead of a rising, billowing cloud, you'd get an instantaneous, brilliant flash of light and intense radiation. X-rays, gamma rays, and neutrons blasting outwards unimpeded. The energy from the blast would vaporize lunar rock and soil, creating an expanding bubble of superheated plasma. This plasma, composed of ionized lunar material and bomb remnants, would expand rapidly into the vacuum of space. Some of it would be ejected at such high velocities that it might escape the moon's gravity altogether. The rest would fall back down, raining molten rock and debris over a wide area. A significant crater would be formed, its size depending on the yield of the weapon and the depth of the burst. For a Hiroshima-sized bomb around 15 kilotons detonated on the surface, the crater might be hundreds of meters across and tens of meters deep. A common fear when discussing such a dramatic event is whether nuking the moon could somehow knock it out of its orbit, sending it careening into Earth or drifting off into space. Thankfully, the moon is enormous. It has a mass of about 7.35 times 10 to the power of 22 kilograms. Even the most powerful nuclear weapon humanity has ever detonated, the Tsar Bomba with a yield of 50 megatons, is laughably insignificant in terms of the energy needed to alter the moon's orbit in any meaningful way. It would be like trying to change the course of an ocean liner by throwing a pebble at it. The moon's orbital mechanics are governed by immense gravitational forces and momentum. So, rest assured, the moon isn't going anywhere. Its orbit would remain stable, its gravitational pull on Earth, responsible for our tides, unchanged. The primary physical effect on the moon itself, beyond the immediate blast zone, would be negligible in terms of its overall structural integrity or its path through space. The explosion would be a surface event, or at most a shallow subsurface event. Section 5. A sky full of daggers, debris, satellites, and earthly peril. While the moon itself wouldn't be nudged from its path, the material ejected from a lunar nuclear explosion poses a more immediate and tangible threat. When the bomb detonates, it will blast lunar rock and soil outwards at incredible speeds. Some of this debris could easily exceed the moon's escape velocity, which is about 2.38 kilometers per second. This means chunks of the moon, ranging from fine dust to larger rocks, would be launched into space, becoming a new population of meteoroids. Their trajectories would be varied, some heading into interplanetary space, others potentially intersecting Earth's orbit. The primary danger from this debris cloud would be the satellites orbiting Earth. Our planet is surrounded by thousands of operational satellites crucial for communication, navigation, weather forecasting, and scientific research. There's also the International Space Station and other crewed spacecraft. These objects are already at risk from existing space debris and micrometeoroids. Section 6. A world in uproar. The geopolitical and psychological shockwave. If such an event were to happen today, perpetrated by any nation, the global reaction would be nothing short of cataclysmic. Imagine the news breaking. One country has unilaterally detonated a nuclear weapon on the moon. The immediate response would be disbelief, followed swiftly by outrage and condemnation from virtually every other nation on Earth. International bodies like the United Nations would be thrown into crisis. Accusations would fly, alliances would be strained or broken, and the world would teeter on the brink of unprecedented geopolitical instability. The act would be seen as an ultimate display of rogue behavior and cosmic vandalism. The psychological impact on humanity would be profound. The moon is a shared symbol, a constant in the night sky for all cultures throughout history. To see it deliberately attacked, scarred by a nuclear blast, would be deeply unsettling. It would shatter our sense of the moon as a pristine, untouchable celestial body. Fear and anxiety would ripple across the globe. Section 7. The scarred symbol, defacing our cosmic mirror. The moon is far more than just a lump of rock orbiting Earth. It is woven into the very fabric of human culture, mythology, art, and science. It has guided navigators, inspired poets, marked the passage of time for agricultural societies, and served as the first stepping stone for humanity's journey into the cosmos. It is a shared heritage, a silent, luminous presence in our night sky that connects us all. To deliberately scar the moon with a nuclear weapon would be an act of profound symbolic violence, a defacement of a universal icon. This damage would transcend the physical crater left behind. Think of the generations to come. They would look up at the moon, knowing that one of its features, perhaps even visible under certain conditions, was a mark of human destructiveness. It would be a permanent reminder of a moment when a nation chose to use its power in such a shocking and arguably nihilistic way. Section 8. The ultimate question: power, responsibility, and the lunar trigger. The hypothetical act of detonating a nuclear bomb on the moon, while scientifically fascinating to dissect, forces us to confront a deeply unsettling ethical dilemma. We, as a species, have developed an extraordinary capacity to manipulate our environment and project our power even beyond the confines of our own planet. The technology to send a nuclear device to the moon and detonate it is within our grasp. The calculations can be made, the rockets can be built, the payload can be assembled. The raw capability exists, a testament to our relentless scientific and engineering progress over the past century. But this capability brings with it an immense burden of responsibility. The history of technological advancement is littered with examples of innovations initially conceived with one purpose, later being used for others, sometimes with devastating consequences. Nuclear energy itself is a prime example, born from the same science that produced nuclear weapons. The power to reshape worlds, or even just to significantly scar one like the moon, is not a power to be wielded lightly if at all for such purposes.